Hi, I'm Jody Martin. Welcome to this edition of Paulding County Today, where today we'll be at the Coppermine Water Reclamation Facility, Paulding County's most advanced facility. I'm standing in a sea of sludge in a circular clarifier. It's pretty interesting, but we're going to let Michael Carter, the director of the Paulding County Water Systems, tell you all about it.
Good morning, I'm Michael Carter. I'm the Water System Director for Paulding County. Today we're at the Coppermine Water Reclamation Facility here in Hiram. This is one of 3 facilities that we have that provide this service to the citizens. This is the oldest plant that we have. Right now we're in a brand new section that just got completed. The old section is a land application system. This new section is a membrane bioreactor that discharges water to the creek. And I'm about to take you on a tour of the facility so that you can better understand what we're doing out here and see the results of our process. What I'm about to show you here is the actual process flow diagram through the plant. Pretty much the wastewater comes into the first section right here, which is the headwork section of the plant. What happens there is pretty much physical treatment of the sewage coming in the door. Through the fine screens, anything bigger than a 3 millimeter particle gets removed there. Goes through grit removal, which removes sands, things like that. From there it goes through another set of flow measurements and goes into the MBR splitter box. And the MBR is the membrane biological reactor, and that's where all the biological treatment of the wastewater occurs. What you have listed is you have an anaerobic basin, which is literally 0 oxygen. There is no oxygen present in that basin. You have an anoxic basin, is another 0 oxygen basin. Then it goes into the aeration basins and then into the MBR basins. What occurs here is nutrient removal and organic removal out of the wastewater that comes in the door. In the MBR basins, that's where the membranes for the plant are. This is a membrane biological reactor facility. The membranes are literally just solid separation is what happens there. They separate the solids, which is the bugs, the biology that consumes the organics and nutrients. It goes through the water goes through a membrane. It holds all the solids on one side. We get clean water coming out the other side. From there it goes to UV disinfection. The disinfection, what happens there is any leftover bacteria and viruses and things like that get deactivated when it goes through this UV light channel. From there it goes through another flow measurement, which is our monitoring point for the plant. That's where we monitor the performance of the plant to ensure that our permit limits are met. Goes from there into cascade re-aeration. What it does, it goes down a big step aerator. From there it goes to the creek, and that's the whole process in a nutshell. What we have right here is an overview of the whole plant. Right now we're standing right here in the control building. As I said a while ago, the headworks, which is the physical treatment of the wastewater. This is where water comes into the plant from the collection system. Goes through influent measurement so we know how much comes in the door. Goes through the screening, through the grit removal. Then goes over here to this is the membrane biological reactor. Goes through here and goes through the membrane solid separation. Then goes down here to UV disinfection. This is the cascade aerator that I talked about. It's a pipeline, comes down all the way down here and gets to the creek. Side stream to this is this section of the plant right here is solids handling, because as you grow solids, as the biology in the reactors grow, you grow MAC. In the water, we keep it at about 1.5% solids, or 1,500 milligrams per liter of mixed liquor suspended solids. As this grows, we have to waste those solids off. Those solids are wasted over here into the sludge holding tank. And from the sludge holding tank, it goes to the solids handling building, and what happens there is just dewatering of the solids. We increase the concentration 1.5% up to right around 20% solids. The solids get dumped into a roll-off box and they are sent to the landfill. Now we can go out and actually see the process. Right now we're in the lab portion of the plant. This is primarily, we do all control tests to determine plant performance here. What we have here is two beakers, one of the influent, this one of the effluent that we send out of the plant. This water is what goes to the river. The influent here is the water that we receive out of the collection system from all of Hiram and all the way up to 120, all the way over to New Hope, back down just south of Hiram, all the way over to the Cobb County line. This is the water that we collect in the wastewater system, which we call influent here at the plant. This is the effluent that we have, which is the treated wastewater that we send to the creek. Quality of this water is a great deal better than the existing quality of the river. So by sending the wastewater we send, it's improving water quality in the river. Just to show you what it compares to tap water, I'll get an extra beaker over here and put some tap water in it. We'll set beside it. This is the tap water it's a drinking water that we have in Paulding County, and here is the treated effluent, the treated wastewater. Right here behind me is the influent to the plant. The influent comes in here. This is what this big building that you're seeing is the headworks. What happens is influent comes into this big chamber, goes through influent measurement here, which is a partial flume that's inside of this channel. Inside of the building is two 15 MGD screens. What they are is rotating band screens. They have 3mm perforations, so pretty much anything bigger than 3mm in diameter is removed, and it goes through a screening compactor and it's dumped out into these two little small dumpsters right here. As you go on through the back side of the building here, where the aluminum handrails are at, there's two grit chambers over there, and what the grit chambers do is remove any type of sands, things like that's abrasive materials that would pretty much damage the membranes. From there, we go into the MBR basins. Right here, we're entering the membrane biological portion of the treatment plant. On both sides of me, one is the anaerobic basin, which is zero oxygen in this basin. The other is the anoxic basin. Primarily what happens here is nitrification, denitrification is happening in these two, and we also get, it's the beginning processes of phosphorus removal. Here we enter the aerated portion of the treatment plant. This is primarily where all of the organics get removed from the treatment process. It flows through these basins into the two membrane basins, which are now on both sides of me. I mean, this is where all of the membranes for the plant are located at. As I said earlier, primarily the purpose of the membranes is solid separation. As you can see, the mixed liquor that's in the basin, it's very thick. It's about a 1.5% solids, and that's primarily the bugs that treat the sewage. Okay, following the membrane bioreactor here, you primarily have a split of processes. You have solids going one way and clean treated water going the other way. The solids is a byproduct of the treatment process. It's a biological process, so you grow solids. You constantly have to weigh solids to keep a normal concentration of solids inside of the membranes to keep the treatment processes working. Right behind us is the solids handling tank. That solids holding is primarily all that tankage serves as. From the tank here, it's pumped over into the big square building right here behind me. Inside of that building, you have a single centrifuge in there. The purpose of the centrifuge is just to dewater the sludge that's in this big round tank. After dewatering it, we go from about 1.5% solids up to about 20% solids. And from there, the solids get dumped into a roll-off box here, and it's sent to the landfill. Inside the building here is the centrifuge. Falling behind me is the solids after they come out of the centrifuge, falling into this big roll-off box. Have a sample of it here on this shovel. I'll show you what it looks like. Kind of looks like pot and soil and is about the same consistency. Here we're standing on the UV disinfection portion of the treatment plant. This is pretty much the final stage of treatment that we have out here. In this trench is the actual UV bulbs. You can see it probably will just look like a little light blue, whitish stripe on your screen, but that is the UV light that deactivates the viruses and kills the bacteria. Standing on over here behind me, this big purple structure is the plant water pump station. It gets treated water, and we use it for treatment processes. We use it for wash down water inside the screens. Any other uses that we need for wash down water here at the plant. Leaving there This big concrete structure over in front of me is the cascade aeration. That is the big step aerator. It leaves from there and goes to the creek. If you want to come over here, we can look at that. And this is the last step in the treatment process. State requires us to re-aerate the water prior to it going to the creek. So that's the purpose of this big step aerator. Gets aerators, the dissolved oxygen in the water increases as it flows over each step. It goes from here into a pipe all the way to the creek. And here we're standing at the actual discharge where it hits the creek right here beside us. The creek, this is just a little feeder creek into Mill Creek, which is another 100 yards or so downstream of where we're at. This is the final step for us. This is the disposal point. End of the road for the wastewater.
Well, that wraps up this edition of Paulding County Today from the Coppermine Water Reclamation Facility. I'm Jody Martin. I hope you found this interesting and informative, and I hope you understand more what water reclamation facilities do. Thanks. We'll see you next time.
Two, one.